Good afternoon, ladies and gentlemen. Let's start our plenary session. This is our last plenary session for this conference. And I think Professor Bertram Murugan Lumalai, he is busy. Yeah, you are coming. He will introduce me, and then I will introduce our panel members. And this session, the topic is AI, artificial intelligence in earth sciences.
Good afternoon, colleagues. I know about Lee. Lee is very perfection and punctuality, but I'm still busy with the people to moving inside. That's what is a bit delay. I'm really apologies for the chair of the session, also the panel members. Colleagues, I would like to introduce, my job is just very simple, just introduce the chair of the session, then I must get out from the stage. Okay. This plenary, I think this is the last plenary sessions, is the plenary session 5, the AI technology in earth sciences. The chair of this session is the Professor P.U. Lee. The Professor P.U. Lee is my friend. He's more than 10 years. We are working together. But he's a full professor and Vice Dean of Chang'an University. He is also got his PhD, obtained his PhD from Chang'an same university. Then he's become the Dean of the faculty. It's a great achievement what he done. Then over the past 2 decades, he has developed an extensive expertise in the groundwater quality assessment, hydrogeochemistry, and groundwater modeling with strong focus on irrigation impact and porous media studies. He has led and contributed more than 30 national provincial research projects, many funded by the National Natural Science Foundation of China. We both got another project, one project from NSFC and NRF 2017. So Prof. P.U. Lee has an exceptional publication record with over 200 international journals, including more than 150 SCI papers, 22 ESI, top 1% highly cited papers, and Nature article recognized among the top 10 highlights in 2014. He has also authored 12 textbooks and monographs, one which received the Shaanxi Provincial Excellence Textbook First Prize. His long-standing contributor emphasizes advancing groundwater science through the research, education, and global collaboration. Also, Professor P.U. Lee is a editorial board members, also the is editor-in-chief of many international journals. So I don't want to read, I think the list is too big. So I would like to conclude this. I'm hand over to Professor P.U. Lee to continue this session. Thank you. Thank you, Chair.
Thank you, Professor Bertram Murugan Lumalai, for your introduction. For this session, we have 5 panel members. I will introduce them one by one. First one is Professor Shafiq Adams. Professor Adams is a senior research manager at South Africa's Water Research Commission with extensive experience in groundwater and water security research. He currently oversees the water availability portfolio and contributes to national climate adaptation strategies as a member of the Presidential Climate Commission. Welcome, Professor Shafiq Adams. The second member is Timothy Dube. Professor Timothy Dube is a professor of geoinformation science and Earth observation at the University of West Cape where he also serves as the director of the Institute for Water Studies. He is also an adjunct professor and a data scientist with the United Nations University, with research focused on applying satellite remote sensing, GIS, and data-driven methods to water resources, land use changes, and environmental management. Welcome, Professor Timothy Dube. The third panel, Professor Mohammed Abad Al-Hasset. It's a long name for me, too difficult to pronounce. Professor Mohammed Abad Al-Basset is the director and the founder of the Arid Region Water Research Center at Soil Palaget University in partnership with the Water Research Commission. He is an academic and NRF-rated researcher. His expertise lies in applying remote sensing and real-time technologies to address critical hydrological and environmental monitoring challenges in water-scarce dryland regions. Welcome, Professor Mohammed. The fourth panelist is from Professor Kawawa Banda. Professor Kawawa Banda is an associate professor in water resources management at the University of Zambia and a 2024 Oliver Tambo Research Chair in Water Conservation. With a PhD in environmental engineering, he leads the Integrated Water Resources Management Center. His expertise spans groundwater, hydrological modeling, and remote sensing. He also manages the African Groundwater Network, strengthening groundwater research and training. Welcome, Professor Kawawa Banda. The fifth panel member is Professor Reid Brown Mapeo. Professor Reid Brown Mapeo is a professor of geosciences at the University of Botswana, where he has taught for over 20 years. Beginning his career at the Botswana Geological Survey in 1985, he later led his regional geology mapping division. His expertise lies in structural and regional geology, remote sensing, and tectonic evolution of southern Africa. He is the editor-in-chief for the Journal of African Earth Sciences. Welcome, Professor Reid Brown Mapeo. So for this plenary session, we will discuss the AI technology in earth science. As I believe our delegates have already noticed, since last year, the ChatGPT arose like a star. It changed our life. It changed our style of working. And actually, before the ChatGPT is released, we have a lot of artificial intelligence technology used in earth sciences. So this technology is changing fast. Our lives, our working styles, everything. I think we have students sitting here. For my students, 2 years ago, I have to edit every sentence of their paper. Every sentence. But now, their English is improved because of ChatGPT. They use ChatGPT to improve the language. But this is just one small aspect of the application of AI in our work. Today, we will have an in-depth discussion on this topic from the perspective, origin, challenges. We will discuss all these things. At the very beginning, I would like to invite Professor Shafiq Adam to give the plenary session talk. Welcome, Professor.
Thank you, and thanks for the title, Professor. I'm not a professor, I'm a doctor, but I go by the name Shafiq. So today I'll talk about integrating AI in water security strategies and give you my perspective and our perspective on how we think it should be used. But I have a bit of a problem with AI, and I'll show you. So a week or so ago, I went to the hardware and I said, I'm going to buy gas geysers. So I put in can I link 2 gas geysers, because 2 geysers were on special, and I wanted to, and I asked him, and he said, yes, you can. And then I started to make some assumptions. And when I got home, I said, hey, did I do the right thing? So I've contacted the technical services. So I spoke to an actual human, and the guy said, hey, sorry, ChatGPT, or I think I was misled. So it shows to me that it is important to have the human in the loop and not over-rely on AI technologies to make decisions. It's more so in earth and environmental sciences. So this was a very costly exercise of me and trying to be clever and think, etc. But technology is a problem for me. Okay. Also, I must state, it's after lunch, it's the last session, so I need to be a bit controversial to stir the room for the discussion. So technology can also be a problem. And how is that a problem? So if you look in South Africa, this is our rainfall monitoring stations. And you can see it's taking a nosedive at some point. Because someone at some point said, okay, technology plus other factors, we can replace rain gauges with other things, with technology. So remote sensing came on board, radar system came on board, tipping buckets came on board, but it had a consequence. We did not know how to manage that technology. And that technology, in fact, could not tell us whether it was raining. It showed clouds, we could model a lot of things, and then this is the problem if we adopt technology without understanding what it means. So a few years ago, we started to do a few projects. So you'll see our partners on there. So the Water Research Commission were implementing. So it was funded by USAID. We had the USGS, the SADC GMI guys, who had SWP, and we had the IBM research labs in that. So we said, okay, how can we use big data, machine learning, etc., with the data that we have? And we tried to do all sorts of funny things. We quickly realized that all these tools can give you causal relationship, but it cannot unravel what we wanted to know. Similarly, with the next study, this was a program, so it was a suite of studies. Same thing happens. All of a sudden, we ran into data problems. So these machine learning and these technologies are extremely data hungry. Okay? And similarly, again, in some cases where we had data, but when we tried to do a transboundary things with our neighbors, they collected it differently, etc., etc. And again, we ran into problems with it. But what was beautiful was we could default to our old methods and still solve the problem. So because it was a research program that looked at big data, machine learning, we all tried to go into that direction. But when things started to came apart, we could default to the more classical things. So some of these things have their challenges, and we all know them. I'm not telling you can read them, etc. But it also has an high initial investment in doing some of these things. So we need to be careful in doing some of these things. So this is wherever I go to a meeting. So I was sitting yesterday when the deputy minister and everyone was talking. So then I always put down some of the challenges that people say. So it's not me coming up with this thing. So I always like to ask myself, what's the root causes and what is the symptoms? So what's causing water insecurity in the system? And often people speak from their perspective or how they were trained, never looking at it as a complex problem. And it is a complex problem wherever you go in the world. And of course, these symptoms and root causes have some relationship through this vicious cycle that we like to talk about. Okay, so we then need to say, okay, but how do we solve this? Because if you really want to tackle water insecurity, drilling more bowls, understanding aquifers better is not going to get you the water security. It might give you some water availability, but it will not give you water security. So we need to look at it. And again, if we look at the catchment scale and we think about integrated catchment scale, we can then use AI in a variety of spaces in that. So, and again, you can see there's a complexity within a catchment. It's not as simple as we often train our students, etc. There's very physical, sociological, technological, you name it. And of course, one of the things that we do not do well is we do not understand fluxes that well. We think we do not. Okay? And similarly, if we go to a settlement or maybe a municipal level, again, you see there is this linkages and connectedness of a system. But what do? We start to break them into administrative units. So you have the roads department, you have stormwater, you have etc. So, and again, we break them up, but nature does not know that. Fluxes does not know that. Vectors and the flow of contaminants, etc., does not know whether it sits in a different administration with a different budget and a different way of doing things. So and again, there's this complexity that keeps on coming up all the time, and we think we are clever by making the complex less complex. And again, so we need to find ways. So, and again, if we just think about a simple, complicated, and complex system, how these different factors interact, okay? So, and to me, this is where the power of AI is. Because a simple is a probably cause-effect relationship. We can do it complicated. We can go through a variety of iterations to do things. But the power of AI might be in solving some of these complex problems. But again, the individual parts need to be well understood, need to be well characterized, etc. Okay? And then keeping the human in the loop. I can tell you, you can come with your AI model. We take a simple model and we put people in the system that says, well, let's do a participatory model. Let people, because some people sit in head office thousands of kilometers away, model the system, etc. But people will tell you, no, that spring is actually only flowing for 2 weeks in a month. Well, you model it as there is a consistent flow for 1 year. But that type of things, you can only, so we found very much power in this type of approach, and it improves, our research managers will tell you that I think it improves it by 60 or 80%, any model, because it is now taking it, making the black box less black, I guess. So again, for us, if you want transformational impact in whatever we do, we need solution integration, we need a plurality of stakeholders, we need better data, etc. And I think this is where AI can come in, etc. But again, you need to constrain. But AI is not the goal. And I think often when people say, it's going to change, it's not going to change. Because if water security is the destination, hydroinformatics is the compass. And AI is the wind in our sails. I borrowed this from somewhere, I can't remember where I've read it, but this is it. And often people say, no, but we have AI can do it now. But we've heard, without proper data, without contextualized data and information, it's going to be useless. You're not going to be able to trust it, etc. Or you need to think, so how we can, and I've heard this since yesterday, the predominant theme is, what's our data like? What's our monitoring like? How do we curate? How do we collate, etc.? And those are the fundamental things. And this is what those projects taught us in the beginning. If you don't have that in place, whatever machine learning or artificial intelligence you throw in, you all know garbage in, garbage out. Okay? So we need to be very careful not to oversell AI at the expense of doing the simple things and the fundamental things correctly. So, of course, there are areas for development, data integration and analysis, predictive, etc., making things faster, more efficient, etc. But you need to be able to trust this thing. So, where I work, we're starting to fund what we call artificial intelligence, and you'll see in bracket, Internet of Things type of thing. So, we don't put a lot of money into it. We start training the system to get used to it, and we do not necessarily think. So again, how do we use agentic and generative AI? I think both of them has a role to play. So for example, if you have enough data and you can train to tell you and build and help, even with this public awareness, be able to translate what, and take the complicated and the complex and make it simplistic, etc. So what's the take home? To improve AI use in water management, hydroinformatics must provide the data backbone. I think if you take that, and often we stop talking about hydroinformatics and we start to talk about other things, and ensure that humans and the environment remain in the loop. It's an expensive lesson that I learned. So I think that was my 10 minutes just to set the scene and maybe to stimulate the discussions going forward. Thank you, Chair.
Thank you, Professor Adams. So as we can see, the AI is transforming every field in earth sciences. I believe in the future, more and more AI technologies will be invented and be applied in earth sciences. For example, in China, Chinese government is now trying to set up this smart system for river system management. I think they are doing this project. So in our geosciences, in our geosciences, we have still a lot of work to do compared to the surface water research group. And there are still a lot of challenges also. So now let's move on to the next program. Next program is the question and discussion. To save time, I have prepared some questions, and I will ask the question so the panel member can answer or discuss this issue. For the first question, it's about the application and the impacts of AI in earth sciences. You know, AI is transforming many fields. What do you see as the most exciting or impactful application of AI in earth science, and why?
Thank you very much. Is it working?
Yeah.
Thank you very much, Prof. Well, I come from an ecosystem, educational ecosystem. As we may imagine, the kind of things that may be affected by AI. But generally, we all agree that AI helps us process large data sets. Big data can be easily handled by AI, but at the same time, like the previous speaker has indicated, human intervention is necessary so that what I saw this morning in one of the presentations, one of the chairs says trash in, trash out. Therefore, in AI as well, some of the data that is being handled, it will need, because this system is non-filling, it would need human intervention. Now, where I come from, in the educational sector, the challenge with AI is that some of the traditional methods of learning, of teaching, can be easily jettisoned out. And it becomes a problem in that way, that the advent of this technology may create problems for us in the future. I also handle a journal, the Journal of African Earth Sciences. And in there, we've got guidelines as to how we deal with AI. We require that you reveal upfront what you have done with AI. Normally, we encourage it for improving language, readability of the paper, not for generating data and putting paper and send it us to review. And we know one journal was stopped from publishing for a year because the whole volume had papers generated by AI. That is one of the challenges that we'll have in the future. Thank you.
Okay, thank you very much, Chair, for the opportunity. And yes, I would like to mention, beside what Prof was mentioning, regarding the AI actually becomes, to some extent, a necessity, especially with the type of data that we have currently. So the big data and the multidimensional data that we have make it quite difficult actually to use a conventional method to analyze the data, that's number one, or to visualize the data. Now I can talk, for example, in some areas where the AI can contribute actually to a large extent. For example, like we came across different paradigm for the hydraulical modeling. And one of the main issues that with the models that is a validation issues. And the second thing that also important for the model is the mechanism of the model, how the model is working. So there is many actual colleagues, they say that all the models are wrong, but some are useful. So the issue of AI actually is bringing us back to that level of black box where we don't see actually what is the physical or what is the processes that running inside. So for the people that use, for example, conventional type of statistical analysis, they would like to look, for example, for the regression, and after that they need to see the model that they can apply different variables to that models, and then parameterize the model, and then after that get, for example, the output. So the AI actually cuts that part related to the understanding of the physical or the mechanism of the model working. However, on the other hand, the AI is giving a large opportunity for the optimization. The same hydraulical models, if we are using, for example, AI, we can easily actually optimize our model, and then it will optimize the model actually accurately better than any maybe like different statistical models or other tools that use, for example, the conventional way of parameters estimation. So there is a lot of areas even that related to the water application, related to agriculture, anything that has a word precision, I guess it can imply something of using the AI. The people tend to look at the AI as only, for example, ChatGPT, Gemini, for example, Grammarly. However, the AI, even in the machines that we are using, the washing machine actually has some level of AI. If you look back, usually most of the people, they don't remember that in the washing machine, usually they put A and N, so which stands for artificial neural network. So most of our washing machines actually is using artificial or using some sort of AI. So then it can optimize, for example, the level of water that can apply, maybe sometimes for the advanced one, even the detergent that they can apply. So there is a lot of opportunities maybe on the AI, maybe for Dr. Shafiq, the thing that relate to the technology. I guess sometimes the problem, the way that we are using the technology. So whether we are actually obsessed about technology itself or we would like to produce something out of that one, I guess like I can classify myself on the old generation. I'm old, okay. So I think we have that kind of usually resistance for the change. But AI came and it's not going anywhere, and it will go for any details of our lives. So now we need to either adapt or find, for example, another planet. Thank you.
Okay, thank you very much, moderator. I also come from an education ecosystem. And for me, almost all my students are using AI. If it comes to assignments, it comes to work, you can already see that we need to change even the way in which we provide assessments, also just to grade that critical thinking of our students. I think AI is really a disruptor in as far as how we're going to do training into the next generation. But coming to what I feel is maybe something remarkable that AI has been able to do. If you've been doing coding, you've been doing some programming, in the past we used to take months on end to debug, to check that the model is working properly, to make sure that your coding and your outputs talk to each other. But with AI, we've reduced those routines to, within 2 weeks, we can produce something very meaningful. Across different types of models, systems. This is AI that has enabled us to do these things smarter, much faster, in an efficient manner. For me, that's very remarkable. What is missing, however, is that people still miss that critical element of understanding the physics behind, the science behind what AI is giving us. I think there is need for more training in as far as how to use AI in an ethical manner, also to make sure that we don't lose the idea of critical thinking and making sure that, especially in earth sciences, that what we are producing as outputs can be interpreted and can be used in the end. I think one of the biggest challenges also is who controls what these large language models are giving us. I think we also need to look, maybe it's a challenge for Africa, we also need to maybe invest in supercomputers that also preserve some of the information. It's very easy to spin a narrative now with AI, and we must also be sensitive to that. We need to make sure that there's some responsibility attached to the way AI is used, in my opinion.
Yeah, I think in AI there's a big opportunity. We always complain, and as a funder, I always get the complaint. We don't have enough monitoring stations, we do not have enough data, etc. So it is an opportunity to say, if a country has an AI or a sector has an AI strategy, because this thing is the data hungry, is an opportunity to motivate, to install these systems to run the AI. Because often when people speak around AI, it is like it's the silver bullet. It's not a silver bullet. As I say, it's the wind in the sail. What comes before that is the monitoring systems and then the data collection systems. So the opportunity is to say, hang on, we want to solve some of our complex issues, we want to automate some of our issues, but we need to invest in the monitoring systems because you can't have AI without that. So I think, and often people complain we do not have enough monitoring, we do not have enough monitoring stations, etc. So we need to then say, okay, but if we want to use AI, because we must accept it's the new global buzzword. And to me, the other huge benefit is if you have all this data, so if you read, for example, I like to read medical journals, I don't know why, but they use it a lot because they have a lot of clinical data. And then they can unravel hidden relationships that normal things cannot do, etc. So again, so to me, that's also the power. Once we have all the data, now we can start seeing things that's always been hidden from because we use traditional methods also. Thanks.
Thank you, Professor. Professor Tim?
Yes. Yes. Thanks very much, Chair. I think that's a kind of a good question. But from where I stand, I don't see AI as a threat, like what my previous colleague has said, because it's something that we already have, and it's no longer it's not reversible now because it's already here with us. And if you look back when COVID occurred, we were supposed to work from home, do teaching from home, and kids were supposed to go to school and study. Otherwise, we could have lost 3 or so years. Yes, we may debate on the quality of the products that came out of that training during that particular period. But at the end, it is AI that allowed us to have progression in terms of our teaching activities. Long back, we used to have meetings. Maybe we have a one-day meeting, let's say in Berlin, in Germany. You have to fly for 2-3 days going there, only to go sit for a meeting for 3-4 hours. And then we are back. Imagine the fatigue. But now AI has made it easy. You can just attend those meetings wherever you are and come up with actionable decisions with all panels available from across the world. So in other words, it has made it very easy to do the work. And then the other issue that I would like to raise is that, yes, of course, we may say it's a threat, but I think we have to view AI contextually. It's a threat to what? Under what circumstances? For instance, these days we experience lots of floods. We see a lot of climate change, droughts, issues of water security. We have got bulks and bulks of data that is available out there. And for us to really understand the processes that explain what we see, we need long-term data. And long back, some of these statistical tools that we used to have to analyze this data, they take time. And sometimes they never help us to achieve the intended goals. But now with the AI, you can process huge data sets, terabytes and terabytes, petabytes and petabytes of data. I think from a water security, from an earth science perspective or water security perspective, what we need is to ensure that we invest more in capacitating people who are in that space for them to be able to handle AI-related issues. That's what we need. Because once we see it as a threat, we pull back. And therefore, we are likely not to go anywhere. But the world, that's where it is. It's moving towards now. And then the other thing that I would like to add is that from a student, from an academic perspective, I know it's an issue. I know universities are busy now trying to draft AI, what you call policies. And students are being penalized for using it. But I think we should adapt, try to change. I know it's very difficult because I have my own way of doing things. It means maybe I have to change my assessment approach, like what he said. Even the way we teach, we have to change. But that's what we should enforce. Instead of saying we will focus on penalizing them if they do, but it's there with them. They use it. You ask them a question like the one that you posed there, they'll just go to AI and search, and they get all the answers. So there's no need for them to go to the library. So we have to change the way we do things. Even the curriculum has to change. I think those are issues that we have to look into. Thank you.
Thank you, Professor. It seems AI has changed our life, has brought a lot to our daily life. And I have noticed there have been many institutes, new institutes, and new institutions in China be set up to deal with AI-related issues. And I think there are still a lot to do for us, both challenges and opportunities. So I hope we can grasp, we can use the opportunity and address the challenges brought by AI. So considering the time, I will not ask a question. I will give the right to ask a question to our audience. So we can have open questions from our audience. Please, who have a question? Yeah. So, please pass a microphone to Professor.
Thank you very much to the panel for a really interesting, refreshing perspective. And it's so nice to hear, particularly Shafiq, saying that we need to keep the human element in the chain. I was at a meeting, an ag tech meeting a few weeks ago in the States, where they had the perspective that AI is going to take away all our problems. They put up a curve of artificial intelligence, sort of an IQ curve, and they were saying that, in the last few years, AI has gone from about a 70 to about 130 on this IQ curve. And my question to them was, well, doesn't this worry us? What happens when it gets right off the end and beyond our intelligence? So my question to the panel is, we know its limitations, but are you worried in any way the other way around, and that it's going to be something that gets out of hand, goes beyond what we can control, or into realms that we don't really understand?
Thank you, Professor. Thank you for your question. Is there anybody who can answer?
Yeah, let me try, and thanks, Jude. I do think that's one of the dangers, because maybe someone takes it, this thing knows better, but I can tell you, it's just take our complex fractured aquifers in South Africa. There's no model that gets it right all the time, and because AI, we will feed the information, so it relies on learning what we give it. But a fractured system is extremely complex. It's extremely unpredictable. We've seen 2 meters away from each other, system behaves totally different. And to me, that is when people start saying, when it starts running away, is that we need to believe what it's saying. And I think that is where we always need to constrain it with real life, either experience or data. And that's why one of the studies that I showed is that everyone said, no, but this is the nice map the simple question that we had in the review meeting, how true is it? Because there's no field data. You cannot say it's true, because we need to constrain it with what you can observe. Otherwise, it's just a nice colorful map. So I do think there's a danger, and I do think that is where we need to keep guard. And because in other sectors, in other professions, it might not need that supervision. But I do think in complex environmental conditions, and that's why I show that root cause symptoms type of thing, because these feedbacks goes all the time. You can maybe train it and the thing will do well, but it cannot account for corruption, as an example. So you constantly need to then either feed it that type of new information to make sure what you get is making sense. But yeah.
Thank you.
No, thank you very much. I think one of the things that perhaps are lagging behind are things like policy. What kind of policies do institutions, do countries, do organizations have with respect to the use of AI? I think if we can start from there, some of the negative aspects can be easily mitigated. Thank you.
Thank you for the question. Actually, is the worry that the machine might take over is not something new. So I remember there was a movie in the late 1990s called iRobot. So where the reports actually thought that will take over. However, the reports, all the people now they see how they improve, for example, the industry, how it helped, for example, in handling, for example, like some jobs that was quite dangerous for human. And what happened for the human actually, just there's some changes that should happen, for example, to the nature of the work that human are doing, either by controlling the technology or by developing the technology. In the field of air science, we had like two studies done on basically trying to use AI to model the rainfall, the daily rainfall in arid areas. And it was a collaboration between the Air Science, the Department of Physical and Air Science, and CSIT. So they said that we would like to generate, for example, 10 years daily rainfall. They say that's not possible, especially we are taking the arid areas where we know that most of the arid areas, they have that kind of high spatial and temporal variability in terms of rainfall events. And said, okay, let's take, for example, data from the previous years, for example, from the 1980s, and then try to simulate the current data. And I get surprised because the model actually did way much actually better than I was expecting. And we then repeat the same work on drought index and on drought assessment. And again, also the model was doing quite good. But we remember that the people actually are doing the coding, the people actually are running the model, the people are planning, for example, the inputs, the people are planning all the aspects that related to the model. And it ended by I got two CSIT interns in my center before I get, for example, anybody from the air science field. Thank you.
Yeah. Professor, anything? No. Okay. Thank you, Professor. Thank you very much for your insightful answers to the question. And considering the time, this session was given 55 minutes. So I think it's almost the end of the session. If you have any more questions to ask, we can communicate after this session. So from my side, I think AI is transforming our life. What we should do is to grasp the opportunity and to face the challenges. Use AI properly. Do not let UI terminate you. That's what I want to say. Thank you. Thank you for our panel member. Thank you for the audience delegates. Thank you so much. After this session, please go to the parallel session directly. We will start the parallel session immediately. Thank you so much. Yeah, I think our panel member, we can take a group photo. Yeah. Hi, photographer. Yeah, we need a group photo.